Hey there, it's Max. In this, we're going to be talking about Unlink Exercise 1 and get you guys started on this fun exercise. So in this exercise, of course, we're going to use the Unlink exploit technique. This allows us to write to an arbitrary location as long as that location is writable. So the where we're going to want to write to is going to be the God entry of puts. Don't worry, I'll explain what that means in a moment. What the God entry is, and the what is the address of the shellcode. In modern computing, most things are going to be read write or read executable, and that's fine. But in our case, we don't want that because we want to be able to execute shellcode. It's more fun, and it's how this technique would be exploited back in the day. So we're actually making the heap executable for this to make it a little bit easier. Although there are other ways you could pwn this thing. So what's the God entry? When you want to load a function from libc or some other shared library, it doesn't just automatically jump to it. It needs to figure out where it is actually located. So the way this works is using the loader. The loader at runtime will figure out the various symbols and how to find that symbol. So for instance, if we think of printf, classic libc function, if it has to go to the loader, it has to do some shenanigans on the symbol table within that shared library, and eventually it returns the address of the library. This is all fine and dandy, but it's really inefficient. It takes a while. Because of this inefficiency, there's what's called the global offset table, GOT for short, and it will cache these pointers for you. So later on, if I call printf again, it's really fast and it calls it directly instead of going through the loader. Now, in terms of exploitation, this is classic. So classic. Anytime there's a writable function pointer, it will be abused. We know this from history. Lots of different function pointers being hit by this. So the God entry is writable, so we can just write to it if we have an arbitrary write primitive. And this is a perfect example of that with Unlink. So we're going to overwrite the God entry of some function in order to use this to get code execution in this binary. So now we're going to look at the code for this. Here we are setting up 3 different heap chunks. One is for our shellcode, and the other 2 are for the actual exploitation. We're then making the heap executable because that's what we need to do. We are writing the shellcode, and then we actually start the exploit process. The free here is fine, but then we have a use after free. And at this point, this is going to be an unsorted bin chunk because of the size of it, and this is using glibc 2.23, which means tcache is not around yet. For that, we're then going to write into it, so we have a use after free, like I mentioned. And this is where we're going to be writing the FD and the BK in order to trigger the unlink chunk exploit. Now, the actual triggering of it, though, is within this free. Remember, unlink chunk is going to be directly below it in terms of addressing. So when we do free victim, it thinks, oh, I need to consolidate this chunk below me. And that's when we do the whole unlink shenanigan in order to write to the arbitrary address. And finally, there's this call to puts. And the puts is the God entry that we're actually going to want to overwrite. By overwriting the God entry of puts, and when this call to puts gets executed, we get code execution, which is really sick. So the start.py is fairly large because we document a lot of stuff. This has a nice diagram of how the unlink works, which is nice. It has some more notes. We have the shellcode, and there's also just a win function, and I was just lazy. I didn't feel like writing all the shellcode. So it's going to be, the shellcode is just going to jump to the winner function. So this also shows the list and the ordering of the chunks. So we have the shellcode, the unlink, and the free. And when we call free here, it will try to unlink this chunk, and that's where the exploit happens. So here, there are only two inputs. There is the fake chunk. Um, that's just that one variable we're going to return. And we're doing the FD. In this case, we're going to treat the FD as the where to write. So that's going to be the God entry for puts. And then the BK is the what to write. Now, the one tricky thing about this uh, is this offset we have to consider. Because remember, when it does that right, it's going to be FD plus hex 18. So we subtract the hex 18 to make sure we're actually writing in the proper spot. So with that, I think you guys are good to go. Have fun with the exercise. I think it's a good one. This is one of the harder techniques to really grasp, though. I remember banging my head against a wall for a couple hours or a long time reading the Shellcode Hacker's Handbook. Thanks.